Okay, now we want to take a look at how a sloped surface or an inclined plane will change how we deal with Newton's laws. So here we have a mass, it's on a surface which is now at an incline. Let's suppose that we're told that this angle here is 30 degrees. And we have a 10 kilogram mass at rest on this surface. And let's suppose we also know the coefficient of friction between the surface and the mass is 0.20. So what we want to know is, what is the acceleration of this block as it goes down the slope? So as always, what we're going to do is start off by drawing in our forces. So the easiest force to draw is always the force of gravity. It's a vector pointing straight downwards towards the center of the Earth. Now, because this block is on an incline, this force of gravity is not perpendicular to the surface. So we want to break that vector up into components that are perpendicular to the surface and parallel to the surface. Okay, this is different than the normal x and y that we use. So a perpendicular component will look like this, and the parallel component this way. So what we have is FG parallel, and I write two parallel lines to show that it's parallel, and FG perpendicular, and here's a perpendicular set of lines. Okay, so we're still looking at components. They're at right angles to each other. This angle here is 90 degrees, but we're talking about perpendicular and parallel to this surface. And the reason we're interested in perpendicular and parallel is that we know the perpendicular component is the component of gravity that's pulling this block into the surface. So that's going to be equal and opposite to the normal force. So the normal force in this case is going to be equal to Fg perpendicular. And this parallel component, well, that's the component that's pulling the block down the slope. So that's the component that will be accelerating the block. And there will also be a certain amount of friction up the slope. And the friction, of course, depends on this perpendicular component now of gravity, the normal force. Okay, so now we have our free body diagram, our vector diagram of the forces acting on this block. What I'm interested in is the net force in the direction of the acceleration. The block is going to accelerate in this direction. So I know that Fg parallel is acting down the slope, and the force of friction is acting up the slope, and the force of friction depends on the normal force, which is equal to Fg perpendicular. So really what I need to know are these two components, Fg parallel and Fg perpendicular. So I need to know an angle inside this triangle. And this is where we have to use a little bit of trigonometry and angles. What we know is that this angle here is 30 degrees. Now that's the angle that this slope makes with horizontal. And if you imagine, maybe let me do this in a different color. If you imagine a line that is horizontal here, that angle in there is also 30 degrees because this line is parallel to the slope, right? So the angle between the slope and the horizontal is 30 degrees. That makes this angle here 60, and this angle has to be 30. So now we know the angles in this triangle. We can go back to calculating Fg parallel and Fg perpendicular. So Fg parallel is mg, but it's only the opposite side of the triangle to that 30 degrees. So it's going to be mg times sine of theta. So mg times sine 30. So 10 times 9.8 times sine of 30. So Fg parallel is 49 newtons. Okay, so we have 49 newtons of force pulling this block down the slope. For the perpendicular component, it's the adjacent side. So it's going to be mg times cosine of theta. And when you put that into your calculator, what you find is that it's 84.9 newtons. Okay, that is the perpendicular component of that triangle. So now we can start working on what is the net force in the direction of the acceleration. So we have Fg parallel acting down the slope, the force of friction acting up the slope. Those two forces combine to give us an acceleration. So Fg parallel is 49 newtons, and then we're going to subtract from that the force of friction. So mu times the normal force, which is 84.9 newtons. And that's going to be equal to the 10 kilogram block accelerates. So what we end up with is an acceleration here of 3.2 meters per second squared. And as for a direction, we can write that this is down the slope. Okay? So that's basically how you handle an incline, right? You're going to break your force of gravity up into two components, perpendicular and parallel, and they're still at 90 degrees to each other. And the key point is that this angle in this triangle is equivalent to this angle over here. If this is 30 degrees, this is also 30 degrees. Okay? The rest is just applying Newton's second law and a little bit of components, vector components, to calculate those two forces. Okay, let me know if you have any questions in class, and try some of the practice problems from the textbook.